10 right there. So, what do we know about the derivative that starts with a C? Negative. So we start there. I might want to just kind of on the side, just like write down. It's going to be -1 over 1 plus x squared. That's the derivative of cotan. That's not my answer because it's not x, it's 4x to the 4th. But that just gives me like my basic starting point. Or maybe it's better to do. Maybe it's better to do like that, like it's 1 plus whatever squared. My derivative here would be -1 over 1 plus whatever squared. The whatever is 4x to the 4th. Times the derivative of the whatever. So that'd be times 16x to the 3rd. But so I would normally write like times 16x to the 3rd over here. But my job is to put it like in one piece. So I would just like write it there. That's the same thing, right? And then you do not have to expand the bottom. I wouldn't. There's no benefit to doing it. You're good. Okay. I highly doubt you're the one that has questions. You're just the one that's asking. What's the directions up there? I don't want to switch back. What's the direction? Find the equation of the tangent line or what? Yeah. Okay. So I'm doing 14. I'm just using this space over here. So y equals blank times x minus blank plus blank. They give me x is, of course, root 3 over 10. Why wouldn't it be that? So I got to find y first. So I've got to plug into there. So I'm going to do sine inverse of 5 root 3 over 10, which looks like it's garbage until you realize that's like 1/2. So it's really the square root of 3 over 2. So I want to find out where sine has a value of root 3 over 2. So like for my tick mark method, I would say that's one sine to the y value, right? So 1/2 square root 2 over 2 square root 3 over 2 is here. So that would be 30, 45, 60 is the one that lines up. Put a pi there, throw it over 180 and reduce it. What do we get? This is the part where you tell me what we get. 5 and 3. Carter, so far so good? Anybody else? Questions on that part? Yeah. Oh, it is negative, isn't it? Dang it. So, no, it wouldn't. Now it's going to be, I've got to put a negative sign here, which is there. So now it's going to be the 4th quadrant. So -1/2, negative root 2 over 2, negative root 3 over 2. That's going to be there. So this is like 330, 315, 300. So I want 300 as radians. So throw it over 180 and reduce it. You might start by just, okay, those are, I can chop off the zeros. Those don't both divide by 6. So you can go 5 over 3. So better? Thank you. So now I gotta find the slope. What do I do to find the slope? Sine is first and 4th one. We're looking like y value wise. So if you look behind you, I mean, I just explained it. There's just a picture. I'm not sure that helps. But oh, you're saying here, right? I think they're both okay. But I like what I know what you're saying now. Let's do that. Oh, -5 over here. Yeah, that's right. Okay. It's fine either way. It's not so bad. So what he's asking is I've got to describe that value. And I think, like, does it say up here, like, negative pi over 2 to pi over 2 or something? Like, in the directions, does it give you a restriction? Okay. He's just describing the point a different way. So instead of saying it's 300 degrees, that's 5 pi over 3, he's saying, well, I'm going to make it negative 60 degrees, which is negative pi over 3. Let's just go in the other way around the circle. So both are good. Okay there? Okay. So now I got to find the derivative and plug into the derivative. Yeah, because I forgot that was negative before. So the derivative of sine, remember that, so it starts with an S, it's subtraction and it's square root. That little cheat sheet there. 1 minus whatever squared. The whatever is 5x, so I put 5x there. Then I multiply by the derivative of that, so I multiply by 5, which will just basically throw 5 on top. And then I gotta plug into that freaking thing. Okay. So I'll have 5 times the square root, negative 5 times the square root of 3 over 10 squared. I would probably make that like negative root 3 over 2 squared. That's the same thing, right? Because like 5 over 10 is a half. So if I square that, so negative squared is positive, so that's not going to be there anymore. What's root 3 squared? 3. What's 2 squared? 4. So this is 3/4. So that's 5 over the square root of 1 minus 3/4 is 1/4. Can you tell me what the square root of 1/4 is? Half, because a half times half will give you 1/4, right? So that's really 5 divided by a half, which is really 5 times 2, which is 10. What if it said normal instead of tangent? What would you put here? Negative 1 times, right? Yeah.
Ideally, could I just leave it as 5
No, because that's not one of the, you can leave addition, subtraction, multiplication, division, not square roots. That's like too advanced. We're supposed to figure that out. Where did they go with this from? I took the square root of 1/4. And then I came like over here. I don't know if that's why you're confused. Where did that squared go? So I put x is negative root 3 over 10, right? So then I multiplied it by 5. And I got this here. And then I reduced it. So 5 over 10 is just like 1 over 2. And then I squared it. So root 3 squared. Yeah, it's like blended into the black. Okay. Okay. I'd like to start 3-6. Is that okay? Okay. So I want to show you one problem first, and then we'll get into the packet. But we're going to do this one first, just on our own. So let's say x squared plus y squared equals 16. I just want to make sure I'm not doing one like from the homework. There's not one, right? Okay. So it's going to ask you to find, it looks like that. What that is saying is the second derivative. Other ways you could write that would look like f double prime of x. Those are the two most common. Those are the two I'd worry about. So we got to find the second derivative. That's what this section is. It's like multiple derivatives or something. Higher order derivatives. So I can do the original, and I'll say like find the second derivative or the fourth derivative or the 80th derivative in some cases, which we'll do in a second also. So I'm going to take the derivative of that. trick at the end. 2x plus 2y times dy dx equals 0, right? So derivative of 16 is 0. And then I would subtract 2x from both sides. Divided by 2y. And then normally I wouldn't simplify, but because I have to move forward with it, I want to make it as easy as I can. So I'm just going to make that negative x over 1. So what I've got now is dy over dx equals negative x over 1. So first of all, the question doesn't get to there. Just the first one. Okay, so now I got to take the derivative of that. So that's a division, right? So I'm going to use quotient rule to do it. So we got implicit and quotient rule and second derivative kind of all in one problem. If you think about it, the kind of problems I want to put in the gateway, it's those like multiple things at one time type of questions. So I'm going to take the derivative over here. The derivative of dy dx that's the derivative of the derivative is the second derivative. That's what this says. Some of you are probably going to ask me why those twos are in like different spots. I'll be honest, I don't remember. I don't care. It doesn't matter like one bit. So don't worry about it. So quotient rule says fig minus gift. So f prime is negative 1. G is y. Minus gift. So g prime, what's g prime? dy dx times f all over the bottom square. Is that part okay? So now there's a couple little like tricks that I'll show you. So that's negative y. I'm going to do this. I don't want you to shout out where it comes from, but I want you to look and see if you can tell me why I put that. Don't shout out. Or you usually love that crazy. What? You can't shout out if you don't know it. I'm going to think they see where it comes from. Okay. So all I'm doing is up here, we know that dy dx is negative x over y. So instead of putting dy dx there, I just plugged in negative x over y. I'm just putting it in that slot. And keep that idea in mind because it's going to come up again when we get to the end of the problem. So, what I've got now is negative y plus, because it's a negative, no, it's minus. It's negative times a negative times a negative. And it'll be x squared over y. Over y squared. So now, along with implicit and second derivative and quotient rule, I've got a fraction within a fraction. So I've got to get rid of that. So I have 3 terms here. To get rid of the fraction in that term, what do I have to multiply by? Y. But since we're fair people, we're going to multiply all the other terms by y also. Multiply that by y and then cancel. Multiply that by y, multiply that by y. So now I get negative y squared minus x squared over y to the third. How's that? So then the multiple choice answer on the AP test would say that. So again, don't shout it out. Let's see if you can figure out what I did there. You can shout it out. Okay. Are you going to answer it if I call you? No, wait. Okay, go ahead. Wait, It's close to the original problem, right? So the original problem, which this was a harder because the original problem wasn't on the board. You guys are all looking at the board for the answer. But if you looked at your book, you might have noticed that x squared plus y squared equals 16, which means wouldn't it have to be true that negative x squared minus y squared equals negative 16? So that I just plugged in negative 16. Question on that one? Is it useful to have you try? Like, I can't really make that much different except for x squared plus y squared equals 25, 49 or something. Is it useful to do one of those? I'm asking you. Will says no, so we're moving on. Okay. Y equals sine of x. I want you to find the 80th derivative. So that means 80th derivative. I want you to find the 80th derivative of sine of x. Please do not take the derivative 79 times. You would, like tomorrow. You could start taking it. Just stop before you. That's like, I think that's the first time. Wait. Hold on, I gotta think. There's one before.
Yeah.
It's a multiple of 4. So, I don't know if you guys have seen the trick yet, but the first derivative would be cosine of x. So this is like the 0th derivative of the first. The second derivative would be negative sine of x. The third derivative would be negative cosine of x. And the fourth derivative would be what? It's sine of x. So the 0th derivative, the 4th derivative, the 8th derivative, anything that 4 goes into evenly would be sine of x. So the 80th derivative is sine of x. How's that? How many other? Questions? Alright, let's do the 1, 2, and 3, 6 in the book. There's only 3 of them, so it should go pretty fast. Why don't you guys try 1 and 2, these first 2 up here. I want to go through this one with you. But try those first 2. All it means, I'll start it. So f prime of x is just take the derivative once. What is happening? I'm my board. Then the second derivative would be like 30x to the 4th minus 24x squared plus 10. Like, it's just take the derivative, do it again, do it again, do it again. The second one's slightly more annoying because you get that fractional exponent. And then you can try it there whenever you want. I'm gonna go through that one like with everyone. Hey, what's up? Hey, what's up? Okay. It's up to him. He's gonna have to make up what he missed. Okay. Okay. Yep. But so is that good for the first one? Second one, I would rewrite it so it was like x to the 1/2 plus x to the negative second, and then this would be like 1/2 x to the negative 1/2 minus 2x to the negative third, and then negative 1/4 x to the negative 3/2 plus 6x to the negative 4. Question on the top two there? Are you like processing or just copying? Like two questions, I guess. Okay.
Overachieve, right? You want to.
Not calling that one.
Well, it's because I redid the drop fractions because I don't want it.
Oh,
So we're calling you lazy.
fair enough. Alright, first derivative here. I'm gonna go to the next. I'm gonna get it open up a new page. Sine y equals x plus 1. So we're supposed to take the second derivative. So the derivative of sine is cosine, but I took the derivative on the y, so I multiply by dy dx. Derivative of x is 1, derivative of y is dy dx, so then we get dy dx by itself, so go ahead and do that. Then solve for dy dx. I would probably bring this over here. And then factor out a dy dx. Remember, there's got to be a 1 there to hold that place, so if you distribute it back, you'd end up where you started. And then I end up with dy dx. 1 over cosine y minus 1. So I'm divided by that, right? Questions there? So you have a choice now to take that second derivative. You can do quotient rule, which might not be too bad. To me, it looks easier to bring the bottom up and do chain rule. Is that okay if I do it that way? Do I care? I'm not done. I'm moving on. So any quotient rule?
Some things will wipe out unless you're
They will. Yeah, yeah. You want, okay, that's fine. Let's do it. We're doing quotient rule. Alright, so fig minus matter. So that's what he's saying. Quotient rule. I think he's trying to point out quotient rule will be easier because this is a constant. So when you take the derivative of that piece, you get 0, and that part of it goes away. Right? So minus, that's fig minus some gith is g prime. Derivative of cosine is negative sine of y times 2y dx. And then the minus 1 doesn't have a derivative. And then f is just 1, so we just have that over cosine of y minus 1 squared. So I could write this as sine of y over cosine of y minus 1 squared times dy dx. Like these two things are being multiplied together. So I could do it this way also, which just kind of sets up a little nicer for the first step. For the last step. So what am I going to put in place of that dy dx? That guy, right? So I'll have sine of y over cosine of y minus 1 times, no, so this is squared, times dy dx, which is 1 over cosine of y minus 1. So they would write their answer as sine of y over cosine of y minus 1 to the third. How's that one? Thumbs up, down, sideways. Little fingers if you want. That's all I got. So go and get to work. Think you're doing every problem, but I'll double check here.
There's no room in the boxes.
I mean, you might at some point have to like use some sheet of paper. Yeah, you're doing the whole thing. Not skipping any test prep or anything. So tomorrow or Wednesday we'll go through this at the beginning. Then we will start reviewing for the Thursday.
They give you this much to do a derivative of minus.
With like dy's and dx's.
I'm not.
You're not having